Hello, I'm Victor Lopez. In this video, I want to make a walkthrough of all the code that I've developed and all the different services that are included in the Palind project at CuresDev. First of all, let's look at the repository, which is this CuresDev Palind. It is publicly available on GitHub, and let's go through the different files that we have. We'll first see how the code is laid out, and then we'll run the Palind backend and see how to work with it. First of all, let's see the files we have here. The paper is this markdown file that has some information. It is not exactly a paper, but it has some information of the methods that we have developed for both tokenizing and linking personal identifiable information. So the tokenization is the process of converting personal data such as names, last names, and so on into binary data. In fact, we use Bloom filters. And the linkage is the process of matching different records that have similar Bloom filters to the same identity. So here we have, in the paper, we have some summary of the experiments we did, and all the code to generate these experiments is in the notebooks directory. Here we have some analysis in the form of Python notebooks for different things. Then, if we go to the tokenizer library, on linkage, let's skip that for now. So the first step is the tokenization, right? So the tokenizer we have implemented both in Python and in JavaScript. So here there's also a spec that explains all the details of this method. So the tokenizer is explained here in this markdown file. And then we have the implementation of this spec in Python, which is implemented here. And let me make the font a little bit bigger, maybe move it here so I don't cover this stuff with my face. We have it here, and then it includes some tests. So might be useful to run these tests. And then we have also the requirements. So everywhere where we have the requirements, it is recommended to just create a virtual environment, install the requirements, and run the tests or the code with that. Next is the tokenizer, the JavaScript implementation. And here we have two versions. One version is this one here, which can run in Node. So we import some Node stuff here. And then we have the browser version, which has the Node stuff removed and directly uses the crypto library and for generating random numbers or doing the SHA-256 and so on. So this is the JavaScript library. It is an exact match of what the Python library does, and it also includes some tests that you can run. To run the tests, you need to, let me go here. So tokenizer JS. We npm test, I think, runs the tests. Of course, you can run npm test because we have this package.json, and here it is defined. So test runs this script. Similar fashion, let's go to the tokenizer, the Python version, and let's run the tests. Okay, this fails because, it fails because it has, so there's one error because it tries to connect to the backend, which fails. We'll soon start the backend and we can run these tests again. So the linkage, this is not, this is from some months ago. So this I haven't reviewed very recently. Oh no, this is just almost empty. So there's nothing to see here. Okay, so let's move to the backend, which is the important, where most of the code is. And here you have a README file that has some information. So how to run the app in development, how to access the admin side, or how to run it with Docker. Some notes about Terraform, we will discuss also later, and then about the database when deploying to AWS. So let's go to this backend and let's try the steps that are listed here. So basically, the first thing that you need to do if you want to work on this code is to create a virtual environment. So with this code here, you create a virtual environment, you activate. I have already created it, so let me just activate it. And well, we could install the requirements. I suppose I already have them installed in my machine. Yeah. Now, to create to access the site, you need to create a super user. So this, of course, I already have it in my computer, but you could run this too. Then migrate. This creates a database, and then run server. So run server is what actually starts the development environment, and we can go to localhost 8000, and we have this login page. If you create a user with whatever credentials, you will put an email and a password, and then you can log in. An important part here is the admin page, and in the admin page, the most interesting things to do are managing users. So as an admin, let's say. So here you can create users, you can make them staff and super users so they can access this admin. So this is important if Sanad needs to be a super user, we need to set this value here. The user must be active to be able to log in. And then, well, we have this organization. So here we also will need to create, when we start up for the first time this project, we will come here to organizations, we create an organization, and then we create a user into that organization. So maybe one thing that I could do is I could delete the database. So let's copy this database to .backup, and let's start from scratch. Okay, so let's migrate. We need to migrate in order to create the database. Oh, I copied it. No, I want to move it. So now if I migrate it, I have just created a blank database. Okay, so let's see what happens now when I run the server. Of course, if I come here and I try to log in with my previous credentials, this will not work because we don't have a super user. So let's create this super user. And now let's log in. We send the same credentials, and now I was able to log in. Now, if we access the admin site, we will see that we only have one user, the one I just created, and we don't have any organization. So probably the first thing I want to do is create an organization, because that will help have everything working correctly. And then we can choose this organization for this super user. Okay. Now, let's go to the site. Now, the site has two main parts. So the first part is this dataset collection. So there's two kinds of users. There's the palin users and the prevalence counting users. The prevalence counting users, okay, now we have a problem. Okay, let me walk you through this too. So the problem with prevalence counting users, sorry, let's start with the palin. So with the palin, what you can do is then you can create datasets, tokenize patient data, and put it into this dataset. So in the palin here, you can create this dataset, and now you can load some data. Sanad has some example data. You generate these tokens, and this will be uploaded to the to this. There's one problem here, right? And you will see this, that this is not loading, and here we can see one error. And this is one of the most important things that you need to do when you initialize this project. So this cannot be blank. What this means is that if we go to the admin site, this dataset doesn't have a disease, right? And in fact, there's no diseases. So if we go back to the instructions here on what to do, there's one thing that you need to do, which is download the human disease ontology from GitHub. So if we come here and we download this JSON, we can check the raw. Let's copy the link. Let's wget this thing. So you do that, and now you import this file, import diseases. So it is very important to import the diseases, because in order to have this counting of the patient, of its disease, and so on, we need to populate the database with this data. So now we come here, and if we refresh, well, we need to run server, refresh this page, and here we have the list of diseases is populated. Okay, if we come here to the admin page, we have this diseases list, and this is all the data we just created. So now this data set that we created initially, we need to set a disease. Now, once this data set has a disease, and you will see it here, if we create a new data set, for example, and we save it, it says disease unspecified, right? If the disease is unspecified, then loading data will not work. We need to have a real disease in order for this to work. We can load new data, and here this is working. Once we have this, so because this user is an admin, we can update the prevalence stats. So we have just, this just happened, and now we can go to the prevalence dashboard, and we will see that there are some patients that have an aspirin allergy. Okay, so this is because we populated the data set for aspirin allergy, and we added some patients. So this is one part of the one kind of the users. So if we come here to the users in the site, there's one Boolean value, which is this is prevalence counting user. If a user is a prevalence counting user, they have more limited functionality. So for example, here a normal user can create as many datasets as they want. Here, tags and source, this is something that you can also manage on the admin side. So here we have tags. So these tags could be, clinical trial, or I don't know, so some other example I have here. So clinical or patient reported, right? So we can save this, and then we can have also some sources. So the source could be a biorepository, for example, biorepository. So once we have populated these values into the admin side, we can select them here. What users cannot select is the disease that they have. So the disease unspecified, I'll make a note to change this label to red, because this is a problem. It's an issue for this dataset. But once the disease is specified, then you can load data. Once you load the data, we didn't see this before, but after loading the data, you can actually download all of these IDs, and this is a CSV file with a mapping of your ID. So the CSV you uploaded had an ID, and the patientids.com value. So we can create a user and make it a prevalence counting user by going to the admin, users. So we create so for example, Victor Lopez plus prevalence. For example, let me add some password and make this a prevalence counting user from CuresDev. Okay. So if we save this user, log out, log in again, Victor prevalence. Now this, as you can see, first of all, is not an admin, so it doesn't doesn't have access to so many things. It just can see the prevalence dashboard. It cannot update it, and it has a default dataset. Again, this default dataset has the disease unspecified, so this is a problem. This will not work. You cannot add new datasets or anything. This is the only dataset that this user has access to. And here, if we try to load some data, it will not work because there is no disease ID. You could, in this case, if you added a disease ID in the dataset, maybe that would work. So let me find some data here in CuresDev backend. Palint backend, patients one. Let's see if this works. Yeah, this is an example CSV that does have some disease IDs. So hopefully this will work. Although maybe not. Okay, it is working now. It wasn't working because I had some changes in the code. So we have now added some datasets. Oh, let me do that again. So load new data, browse, get these patients, generate. We upload all these tokens, but you cannot download the actual patient's ID. You can only go back to the dataset. So this is a different flow that we had before. So this is the product. Here you can log out, change password, check the organization, and log out. So this is a Django app. Let's look at the code a little bit of how this is implemented. So this is a standard Django app. What does this mean? Well, I forgot about these pictures. We had this explanation of how the models interact with each other, right? We have like a global patient, we have a data set, which we saw before. Each data set has a data set patient, and then we have some submissions that can be linked to the same patient. In CuresDev, we have the settings for this project. So settings, this is more or less standard Django settings. We have, of course, customized a couple of things. Here we will have the accounts, datasets, and prevalence apps that we have implemented. And we will go through this code right now. And then here we might have some other customization, like what is the auth user model, where to redirect for logging, and so on. There is no actually an email backend, so this is just printing emails to the console, but we're not sending emails. So we have some settings for specific for production, in which we only allow some hosts running on CuresDev or Amazon Web Services App Runner, and we enable all of the security features and load some data from the environment. In the default settings, we do the same for the database. So the database, if this database secret or DjangoDB user password are set, we will use this configuration. And that's the way we configure a different database for the AWS deployment. Okay. So this is the config. Let's look at the three main applications that we have. So first is the accounts. So the accounts is a pretty simple one. It is mostly for managing the users and the organization. So here we have some models, organization, custom user, which has all these fields that we saw on the admin, right? When we created a user, by default, we create a dataset. So each user has a default dataset linked to it. They will see it if they are prevalence counting user. If not, it will be hidden. Here in the admin, for example, is how we have personalized the look of the admin page. So if we come here to, well, no, I have to log in as an admin. So if we go to users, all of these things here, this table, filtering, and so on, this is all on also the editing, like grouping this login info, organization, personal info, and permissions. All of this is organized here in the custom user admin. Okay, and we have some views. well, a single view, which is this organization view where we see the organization of one user, and we see the list of users. That's very, very, very simple. Second, we have let's look at the prevalence, which is maybe easier, right? The prevalence, it has just some models for displaying the data related to the statistics about some disease. So we have all of these global stats, which is the model that everything stems from. So here on top, we have when it was created or updated, number of diseases, number of contributors, number of patients. And then we have all other stats linked to these global stats. So we have the patients by source, and then we have all the diseases that we have. This is the representation of this human disease ontology data. So all of these fields have some URLs, disease stats, so this is separated for each stat, the level of confidence, number of contributors, and so on. And then we have a single function, which is this count diseases prevalence, that basically goes through all the users in all of the data sets. It links them together, it checks if they are similar, and then it doesn't count repeated users. So if or patients, if one patient appears twice, according to our linking algorithm, it will be counted only once. And it updates all of this. It creates a global stats, patients by source, and so on. So this is the prevalence. There's a couple views, basically for updating the prevalence stats, for viewing the prevalence in the template, this dashboard that we see here. And then we have another one for the data view, which just returns a JSON response. I think it is this .json that returns the JSON response of all of this data. And finally, let's look at the datasets app. So the datasets app is the big one, let's say. It has all these models that we saw previously in the UML diagram. And here we have all of these are similar. This is what we were mentioning before, the way of checking if two patients or two submissions are from the same patient. We have all these tags, source that we added a couple of minutes before in the admin. And then we have the dataset. So these are the datasets that we are creating in the admin. We have the public IDs that are matched to its submission. Then we have the dataset patient. So it's there's a dataset patient that can have multiple submissions. The submission, which is created when you submit some data, when you add some patients to the dataset with all the fields in the spec. So the first name, the last name, etc., etc., etc. Apart from the models, we have these views. So the views, this is a standard Django app again. So we have the models, we have the views. So it's basically the dashboard, some mixins for checking the permissions for accessing the data, listing all the datasets, updating, deleting them, uploading the CSV, exporting the CSV, and so on, and submitting. So this is the API call that is used to submit all the data. And then we have all these demos that I haven't mentioned before, but this is the linker demo and the tokenizer. Well, no, that's an issue. I'll have to recover that file. Anyway, so here we have all the methods for, well, these are the demos, not so important, but this is the API call that is used for creating a submission from the browser. So this is how this backend works. This is the summary of the backend. We see the error we had is that this demo depended on one file that I removed. So I'll have to probably add it back. So what else do we have here? In the backend, we have this Terraform config. So this is the last thing I want to comment is how this is deployed to AWS. So let's open AWS on the site. Now, let's look at this Terraform file. So this Terraform file summarizes everything that we have in this Palen deployment. Okay, so it is deployed on AWS, this region, has some variables. This is for configuring, the environment, the domain name, and so on. This is for the S3 bucket. We only use it for storing the Terraform state, so that way it kind of persists. So, okay, let's log in here. And then we have, the configuration of the secrets. So these are the secrets for the Django secret key, which is actually random. So this is a random password generated by Terraform. Then we have this IAM role for getting these secrets. So we want the app runner that we're using to get these secrets to be able to run it. Then we have this database. So the database is encrypted. It is Postgres. It is only publicly accessible in dev. It is not publicly accessible in production. It's a small instance and has 10 gigabytes. Then we have all of these VPCs and so on in order to configure the actual app runner. So this is the actual app runner service. That is, it pulls the code from GitHub, from the directory backend, and then it installs it by installing the build command. Installs the requirements. It has a port. It runs Python 3. I think it's 3.8. That's AWS dependent. And it has this startup sh code. So startup.sh, we didn't mention this before. It's a very, very simple script that does the following. It uses the production config, migrates the database. So if there's any new migration, it applies them, collects the static files, and then runs the app with Unicorn. So we make the instance publicly available. We have all this VPC, and here we configure all the domains. So the app works on this domain, app.curesdev.com. In AWS, we have 3 accounts: the parent account, the dev, and the production. Let's go to the production, which is probably the most, production and development are more or less the same. And here I have some services in my favorites, which just show you how they are running. So this is app.curesdev.com. This is where the app is running. Okay. And here we have this app runner service, single service, Django. This is what we have configured via Terraform, and this is deployed every time you commit code. Then we have the RDS, which is the database. And if you come here to the instances, you will see that there's one single instance. This is created also by Terraform. In the secrets manager, again, we see the secrets. So we have 2 secrets, one for the database. This is generated automatically by AWS, so we don't need to manage it manually. And then the Django secret key. And all of these permissions, the roles and so on, for the app runner instance to access the other services. So here we have just this role, get secrets role, that allows you to access with this policy the secret that we have for the secret key. So it's a very, very standard thing. So that's the AWS. I think I've covered more or less everything. Of course, if you're working with this code, or I don't know, whoever, if you're watching these videos because something bad happened to me, I'm just kidding. If you have any issue with this code, write me an email and I'll be happy to help.